This video is going to be a quick reminder about how to work with inequalities as well as how to solve equations, actually inequalities or inequations if you will, and graph them on a number line and a few of the details about graphing on a number line. So the first thing we want to remember is what the difference between equivalence or an equation and an inequality such as less than or greater than would be. So first of all, on the left hand side here, if we're looking at it, negative 16 compared to negative 19, well remember on a number line, negative numbers increase in value or increase in size to the left, which means that technically negative 16 is greater than negative 19. So the symbol we use for that is to show that arrow pointing at the smaller number, or the one that is greater, the one that is in larger value on a number line, such as if we put negative 19 here and negative 16 here, the greater side is always going to be the open side. Okay? So negative 16 is greater than negative 19. Now to solve or show the expression up top, negative 4 minus 8, we're going to need to find out what value that is. So that's a negative 12. 16 plus negative 4 is positive 12. Therefore, since 12 is greater than negative 12, it's going to have that symbol. And in our blank, we will put in a less than symbol. Negative 12 or negative 4 minus 8 would be less than 16 plus negative 4. Now, to graph on a number line, it also helps to know what you're really looking at, which you can graph just simple answers on a number line. If we take a look at this equation, we would subtract our 3 first, and then divide by negative 4, giving us a negative 7, which means on our number line, if I label this line negative 7, we're just going to place a point above the line at negative 7. If we're looking at an inequality, and notice the numbers did not change, the same idea holds. Negative 4x, subtracting our 3, is now greater than or equal to 28. And if I divide by negative 4, remember that x is now related to negative 7 the same way it was before. Now realize that, remember, if you have a greater than or a less than symbol and you divide by a negative number, divide or multiply by a negative, we're going to flip that sign. So we actually make our greater than or equal to into a less than or equal to. And now when negative 7 is in the middle of our line, a solid dot, x is also less than. We're going to the left of that point. Some of the basic rules of graphing on a number line. Remember that when there is an equal sign, we're going to use a closed circle because 6 is an actual answer in the example here. 6 is less than or equal to itself. Whereas if it was only x is less than 6, we're going to start our line at 6 and go off to the left, but it's going to be an open circle because if we use the actual number at 6, 6 is not less than itself. Left and right, again, it's just determined by greater than and less than. Typically less than will be going to the left, greater than off to the right. And then finally, and versus or. If we're dealing with a compound inequality, if x falls between two numbers, 4 being less than x, but also x being less than or equal to 9, well, 9 is the top end of our line, and notice or equal to, so solid dot. 4 is the bottom end. But again, no or equal to, so open dot, and x is somewhere in between. So x is both greater than 4. Notice that up here it was 4 is less than x, same thing as x is greater than 4. So our line is going to the right of 4, but at the same time, x is less than or equal to 9, so we're going to the left of 9. And we're only going to have those numbers that fall in between that satisfy both statements. And a great word to think of when you think about and is the word both. Or just means you have to satisfy one or the other inequality. So if x is less than negative 3, notice open circle at negative 3 going to the left, or x can be greater than 3. So we go an open circle at 3 going to the right. And even though those two lines don't cross, there is no such number that would be less than negative 3 and greater than 3, but the nice part is we've used the word or. So you can be either the first one or the second one, or both. If that so happened to cross, then you can kind of determine it at that point. So let's take a look at a few different examples of how that could work, as well as a few sort of trick examples. If you switch that and with or, sometimes it can be sort of a tricky idea. One great idea is to take your inequalities and to graph them separately first to get an idea what they look like. So if we're looking at 6 and -4, I'm going to put those two numbers on my number line, -4 up to 6. Now, the first inequality says that x is going to be less than 6. So I'm just going to go way up top here. I think we'll do that in green. I'm going to say, well, hey, open circle at 6 and x is less than. So we're going off to the left. At the same time, x is greater than or equal to -4. So a solid dot at -4, just like it's technically a solid dot on the line above, since they're both solidly included. But x is now greater than, so we're going to go off to the right. Now our big question is, and which section is on both lines, both the top line and the bottom line? And since we're included at this solid dot, I would say everything from here going out to the right, but again, not including that open circle. And then from here on out, we're only one line. To the left of our solid section, we're only one line, which means when we make our final answer graph, or we put our answer down here, -4 is both less than 6 and greater than or equal to -4. So it's going to be on both lines. 6, on the other hand, is not less than itself. And since the only section is the part in between those 2 points, that's the only line we're going to draw. And only the stuff in red down here is technically the graph for our final answer. If we change that word to an or, we're going to graph those same things. So from -4 up to 6, only this time 6 goes off to the left just like before, -4 goes off to the right, and now the question is, what's on one line or the other one? Or both? Well, everything to the left of -4 seems to be included. Everything in between is on both lines, so that's even better. Note that at -4 you're on both lines. At 6 we're on at least the bottom line, not the top one, but the bottom one. And out to the right we're on at least the bottom line. So technically you could say that all real numbers are a good answer for that one. You had everything included. All numbers you could possibly name, all real numbers, would either be less than 6 or greater than or equal to -4. So you can see where it gets a little bit trickier. Try that with the bottom 4 lines. Pause the video now. I'll put up the answers and you can see how you do. Alright, compare your answers to what's on the screen. Notice that for the middle section, both of our lines technically would have been pointed to the left, both with open circles. So when we say and, it's only the question being, what's on both lines? Well, there's only a single line or no line off to the right side of -1. The double line is from -1 out to the left. So there's where you're in between both lines. And also notice that because that's an open circle, technically -1 is not on both lines. So it's not included in your final answer. It's going to be an open circle. Whereas when we change that to being or, now what's on both lines or just one line? Well, the bottom line technically kind of includes all of what's on the top line. So if you're on at least one line, which means everything from 6 and downwards, then you're in our answer. But again, 6 wasn't included on that line or on the top line, so therefore an open circle to start. The next set of lines is everything greater than 8 and less than 6. Well, the problem is those two lines never intersect. So that would be a none. There would be no possible answer, kind of no solution to that. There is no such number, real number, greater than 8 and less than 6. Also, when you change to or, well now, both lines drawn outwards, I'm okay with being on either one. So really just those two lines drawn will give you your final answer. I hope that makes sense and helps you remember how to graph inequalities. Now, sometimes they're going to give you questions that look like this, where you might have to do a little bit of work before you can graph. So 4 minus t is less than or equal to 6. Well, we need to figure out what t would be, whether that's greater than or less than or equal to answers. So we need to do a little solving. So call that negative t is less than or equal to, let's subtract our 4, it's a positive 4 over here. So we're going to subtract 4, call that 2. And at the same time, since the other side kind of is the same idea, 4 minus t greater than -1, let's go ahead and subtract 4 on that one as well. Now remember, you're only subtracting, so keep your signs the same, but -1 minus 4 would be a -5. Then we've got negative t, so now I do need to divide by -1 or multiply by -1, whichever way you'd like to think of it. But I'm going to divide all the parts, so this becomes a t, because that's negative, becomes greater than or equal to, and 2 divided by -1 becomes a -2. And at the exact same time, t is greater than 5. Now remember, I divided by a negative, so I made a mistake there. I better flip my sign and make sure that that's now pointed the other direction. So it should be t is less than 5. And if we think about our graph, I only want the numbers from 5 and -2, everything that's going to be greater than -2, but less than 5. Since 5 has an open circle with no equal sign there, and a -2 has an equal sign, so it'll have a solid circle. And then finally, again, I want to be greater than -2 and less than 5 all at the same time, so I only want the portion in between those two numbers. Now note that the way those are written, you actually could have written them as one large compound statement. Because 6 is technically on the greater side, so 4 minus t is less than or equal to 6, but at the same time, 4 minus t is greater than -1. 4 minus t falls in between those two things. And you can solve that whole thing all at once. Let's take the same two moves we did here and finish it off. So we're going to subtract our 4 from all parts. We just have to remember to do it from the middle as well as both the left and right sides. So this becomes -5 is less than -t, which is less than or equal to 2, and then finally divide by our -1, and this becomes, oops, don't know what quite happened there, get rid of that, this becomes 5 being less than, now becomes greater than, t now greater than or equal to a -2. And if you want to flip that around, typically we like to go low to high. Well, -2 is definitely less than 5, so if we flip everything around, I'm going to swing this part this way and swing that one over here. -2, notice on the less than side, so it would be less than or equal to t, which is technically less than 5, which is exactly what our graph looks like, t being in between those two numbers. I hope that helps. Again, if you have questions about compound inequalities, feel free to ask your teacher. Good luck and have fun.